Hey folks, and welcome back to our next video. Today we're going to be starting our new unit number 6, which is all about motion. And this is going to be our topic for the next several weeks. We are leaving behind chemistry, getting into physics concepts. So that's what we're going to be getting with today. And today we're going to be starting with distance and displacement. Now, I've got a video here, and I'm not going to show this clip right now. You should pause this video if you're watching it, and if you go back to the assignment, there's a link to, I think a step number 2, it says there's a link to a video. So go ahead and open that up and watch the video clip before you come back here and then continue on with your notes. All right, so I'm assuming that you've watched the video, and there's a lot of motion in that video, right? There's a lot of things moving around, and that's our topic for this unit is motion. So what exactly is motion? Well, motion occurs whenever an object changes its position. So you saw Black Panther, Captain America, right? They were all changing their position. They were all moving around quite a bit. Now, there's a lot of different ways that we can describe motion. In fact, there's going to be 5 key vocabulary terms that we're going to be learning about in this unit, ways that we can describe motion. And when we say describe, we mean how can we talk about how an object is moving, right? Like if we're thinking about Black Panther when he's running, right? How can we describe how he's running? And so we can do that either talking about his displacement, his distance, his speed, his velocity, his acceleration, right? And we can do the same thing for Captain America. Lots of different things that we can talk about here. So again, today we're going to be talking about distance and displacement and what do those things mean. So distance is how far an object travels between 2 points, okay? So if we measure, right, between 2 points, and something walks along a path between those 2 points, that is its distance. Now, in science, the unit we use to measure is meters. Now, in our kind of American life, right, we typically would use feet or yards or miles, right? That's kind of the English standard system. But in science, we use the scientific system, the international science units, and that unit is the meter. You may also hear about centimeters or millimeters or kilometers. Those are all derived from the meter, okay? And the meter is a little bit longer than a yard. It's fairly comparable to that. And so again, that's the unit that you're going to see a lot of things in this class is in meters. Now, if you take a look at the example down here, we've got our little stick man. Stick man is starting at 0, and then he's walking over to 6, and then he's walking back to 2. You'll notice that the total distance that he's covered is 10 meters, right? Because he walks 6 meters to the 6 meter mark, and then he walks 4 meters to the 2 meter mark. And so that's a total of 10 meters that he has covered. We also have another diagram over here on the right. This one is showing the person that is walking along this track, right? And the start and end points are right here, but they follow this entire track. And so therefore that is the distance that this person has walked, right? It's the total path, the total length of the path that an object follows. That's distance. Now, in contrast, displacement is how far apart the start and end of an object's motion is, okay? This is also measured in meters. So again, anytime we're measuring the length of something or, how far something is apart, we're always going to use meters. So in our stickman example, the stickman walks the same path. They walk to the 6 meters and then back to the 2 meters. But because he ends at the 2 meter mark, we only take into account where you start and where you finish, okay? So when we're talking about displacement, we're just talking about where did you start and where did you finish. So if we take a look here, he starts at 0, he ends at 2, so his displacement is just 2 meters. And the other thing you'll notice is that there's a direction here, right? It's showing that it's 2 meters to the right. And that's the other part of displacement that's important. You have to include the direction that the object travels. So it could be north, south, east, west, could be up, down, could be left, right, whatever. You need to include a direction and how far it is from where it started. A way to be able to compare distance and displacement, if you take over here again to that picture on the right, the distance that this person walked was this whole path, right? But the displacement, again, is just where it started and just where it ended, Okay. And we're going to do some examples with this to make sure that we kind of get these two concepts locked into our minds because they're important when we start getting into things like speed and velocity. Now, we need to add a couple of other concepts to our ideas. These are not things that are specific to motion. These are things that we will see repeated throughout the physics section, and those are scalar and vector quantities. So let's talk about scalar quantities first. A scalar in physics includes only a number and a unit. So when we're talking about something that is a scalar, we're talking about something that is just a magnitude, which is just the number and the unit. We're just thinking about how big something is. So for example, distance is a scalar because it's just how far did you go, right? 5 meters long, right? That would be a distance, okay? When we think about a vector quantity, a vector is something that includes a number, unit, and a direction. And so displacement would be a vector because, again, I said that we need to say how far we're going in for our displacement. We also need to talk about the direction that we're traveling. Okay, so 5 meters to the east would be a vector quantity as opposed to just 5 meters, right? Because 5 meters doesn't include that direction. And so we're going to kind of, as we go through talking about speed, velocity, acceleration in our future videos, we're going to be talking about whether or not these are scalar or vector quantities. So again, scalar quantities are quantities that include just the number and a unit. Your vector quantities are number, unit, and a direction. Okay, and so distance is a scalar, displacement is a vector. Now, if we want to compare distance and displacement, right, again, distance is the total length of the path it takes to go from A to B. So whenever you're going from one place to another, distance is the total length of that path. Whatever the path is, however you take to get between the 2 points. And if you take a look over here at our little ladybug that's crawling, right, you can see the blue line is the distance that it is traveling. Displacement is the length of a straight line between points A and B, right? Where you started and where you finished. So the ladybug starts at A, and you can see as it walks, the displacement is constantly changing depending on where it's ending up. And when it finally gets to point B, right, it has a certain displacement, right? That is that straight line between where it started and where it began. Now, your distance and displacement can be equal, but only if the object travels in a straight line. If the object travels in a straight line, then the distance and displacement will be equal to one another. Displacement can never be less than distance. Your distance will always either be equal to or greater than the displacement. And again, it's only going to be equal to if the object travels in a straight line. So let's take a look at an example problem here. So we have a person that is walking from point A to point B, and it is doing so following this red path, okay? And each of the squares is representing 1 meter. So the question is, what distance did they travel and what is their displacement? So let's count up the distance first. If we start with A, what we want to do is we want to follow the path and count up the number of squares that they travel, because each square, again, represents 1 meter. So we've got 1, 2, 3, 4, and then we're making this turn. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we want to make sure to count this last one, 15. So the distance that they traveled is 15. And this is something that I'm going to be a stickler about, okay, for the rest of this year. So let's get it right from the start. You must include a unit when you are giving answers. If you just say 15 here, you will not get full credit. You need to say 15 meters, okay? Because if you just say 15, it could be $15. It could be 15 clowns. It could be 15 whatevers, 15 pounds, right? If you don't include the unit, you're not being specific. You're not demonstrating that you understand what the problem is, okay? So you need to make sure that you include the unit for every single one of your answers, all right? Now, let's talk about the displacement, all right? The displacement, again, is where did we start and where did we end? It's just a straight line. So we started here at A. Our straight line is like this, okay? So we have 1 meter, 2, 3, 4, and 5. So our displacement is 5 meters. And then remember, there's one other part to displacement. We need to include the direction to the right. Okay, or you could say east if you're into your cardinal directions. Okay, so when you're including your distance, make sure you include a unit, count up the whole length of the path. When you're talking about your displacement, you need to make sure that you are including a direction along with your unit and your number. Okay? So that's an intro to distance and displacement. You've got the rest of your notes the rest of the worksheet to finish out. Make sure that you do your summary and then complete the practice and submit it through Kami. If you have questions, feel free to reach out. Otherwise, we'll see you soon.